Today's notes are actually a refresher of material that comes from way back in the beginning of the year. So if these graphs and these questions kind of look familiar, that's a good thing because we've actually already learned this. We're bringing it back. The reason we're bringing it back is that we have been learning how we can go from radical notation to rational exponents. Like this would be x to the 1/2. This one would be x to the 1/3. So that's knowledge we didn't have before. And we've also learned how to solve radical equations. So today, we're going to bring back our knowledge of radical functions, specifically the domain of radical functions. Let's jump right into our first graph. Notice it says recall because we have done this before. Write the domain for each of the following root or radical functions. For this first graph, when I come in from the left, imagine I drew, let's see where my lines are. Let's say I actually took my pencil so imagine this blue line is my pencil, and I come in from the left. I stop when I hit the graph. So there's my graph. That's going to be 0 with a bracket because there is a point at 0. And then if I take my pencil and I come in from the right side, I stop when I hit the graph. That arrow means it goes on forever and ever to infinity. So 0, infinity. Parenthesis because we cannot equal infinity. If I look at the second graph, I'm coming in from the right first, from the left first, the left side. So again, this is my motion of coming in from the left. I stop when I hit the graph. Here's my graph, but that arrow tells me it goes forever and ever and ever to the left, which would be negative infinity. We can't equal negative infinity, so it's a parenthesis there. Then I take my pencil and I come in from the right side, stop when I hit my graph, and hey look, there's another arrow. Going to the right forever and ever is positive infinity. So the question then says, which of these has a restriction? And if I look, this, another way of saying this, is all real numbers. This graph did not have a restriction. The one on the left did. If we can generalize, this was a square root, or in general, an even root. And this is an odd root. And in fact, any even root, I'm supposed to say odd root. Any even root will have this shape, where we have a definite starting point and it arcs up to the left, or it could arc to the left instead of the right, but the point is it has a starting point. All odd roots look like this curvy line with a bend in it. So the even root function had a restriction. So in general, let's bring back the knowledge of why. These past couple of days, we have reminded ourselves that we cannot take the even root of a negative. So for the domain of an even root radical, cannot take the even root of a negative number need to find the values of x that would make that happen and exclude them from the domain. And we can almost see that from our graph right here because 0 is the smallest x value. I can take the square root of 0. So if x was 0, I'm fine. Here, as soon as x would be -1, that would be a negative under the radical, which is not okay. The domain of an odd root radical, all real numbers. No restrictions. Because you can take the odd root of a negative. So remember, even from last week, the third root of -8 is -2. That you can do. The directions here say algebraically determine the domain of the radical functions. So bringing back that prior knowledge, we are focusing on what's underneath the radical, the even root. So highlight what's under the radical. For it not to be negative, it means that what's underneath the radical must be greater than or equal to 0. If I solve that, I subtract 5 from both sides. We get x is greater than or equal to -5. But that's not my complete answer. I need to make a statement about what the domain is. So we'll say D for domain, all real numbers, x greater than or equal to -5. And now I'm done. If I look, my graph supports my answer, x greater than or equal to -5. My graph starts at -5 and goes to the right. So any value from -5 and bigger is fine. If I had, let's say, -6, watch what happens if we do f of -6. F of -6 would be the square root of -6 plus 5, which is the square root of -1. That would be no solution. Again, supporting why this restriction exists. Because as soon as I choose something less than -5, I get a negative under the radical. For number 2, again, our focus is purely on what's under the radical, which in this case is -3x plus 3. So I take -3x plus 3. I set that greater than or equal to 0. We'll subtract 3 from both sides. That leaves us -3x is greater than or equal to -3. Divide both sides by -3. Remember, as soon as you divide or multiply by a negative, the inequality sign changes direction. So my answer here is domain is all real numbers, x less than or equal to 1. Let's go explore and see if this is backed up by our graph. Here's 1, and notice, anything to the left less than 1 is fine. Let's see what happens if we were to evaluate f of 2. F of 2 would be the square root of -3 times 2 plus 3. That's the square root of -6 plus 3. Square root of -3. No good. Look, I got a negative underneath. That would be no solution. So anything greater than 1 gets us no solution. Just to show you what happens if we use 1, because this says less than or equal to 1. So let's say we let it x be equal to 1. That would be square root of -3 times 1 plus 3. That's the square root of -3 plus 3. That equals the square root of 0. I can take the square root of 0. The square root of 0 is 0. So if I actually substitute in this value, the output is 0, which is as low as we can go and still be okay. 3 through 12 is a mixed practice. So my strategy, let's put a strategy at the top. Find all the functions that don't have restrictions. So don't have a restriction first. As a reminder, those are your linear functions, quadratic, and odd root functions, because a linear function is a line, an increasing or decreasing line, coming from the left, coming from the right, no restrictions. I hit negative and positive infinity. Quadratics are a U-shape that either opens down or up, coming from the left, arrow, coming from the right, arrow. And then odd roots look like that line with the bend in the middle. Again, if I come in from the left, arrow, come in from the right, arrow. So for all of these, all real numbers would be my answer for the domain. So let's go look for those. Let's see if we have any linear functions. No, 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 no. Nope, nope. Still no. No, no. Okay, so none of these are linear. I was looking for something like y equals 2x minus 8. That would have been linear. But nothing looks like that. Let's go look for some quadratics. As soon as I see a radical, I know it's not quadratic. So 3 through 7 right away are not what I'm looking for. 8 has something in the denominator. 9 has a radical. 10, that's a quadratic. Question, does this open up or down? I'm hoping we all say down because of the negative a value. So for 10, no work needed. Quadratic, all real numbers. Nope, nope. Okay, so we've got one quadratic. Now let's look for our odd roots. Even, even, this one is odd. I know it's odd because of that right there. So odd roots look something like that. All real numbers. See if you can find any other odd roots. Number 9 is also an odd root. All real numbers. So right away on this page, we took care of 3 of them and no work was needed. For all of our even root questions, please take a highlighter and highlight just underneath the radical. So notice I didn't highlight the -3, didn't highlight the -9, just what's underneath the radical. Now that we've done that highlighting, let's go back up. The highlighting really helps me to see what I need to work with. So I take what's underneath the radical. We cannot take the square root of a negative, so I set what's underneath greater than or equal to 0, and I solve. So I'll subtract 7 from both sides. I get x is greater than or equal to -7. That's what I need to write my answer. So all real numbers, x greater than or equal to -7, and I'm done. looking at something like number 6, again, I'm only paying attention to what's underneath the radical. That negative out front doesn't matter. The plus 7 right there at the outside does not matter. Just what's underneath the square root sign. So I take 6 minus 2x, set it greater than or equal to 0, and solve. We will subtract 6 first. This is our prior knowledge with solving. Get negative 2x greater than or equal to negative 6. Divide both sides by negative 2. I divide by a negative, so the inequality sign will change direction. So I get x is less than or equal to 3. So all real numbers, x less than or equal to 3. I'll leave 4, 7, and 12 for you guys to work on and show me what you got tomorrow. But you now have 3 and 6 as an example. Let's talk about numbers 8 and 11. 8 and 11 are a little different. These are ones where we have x in the denominator. So let's highlight those denominators. And I hope that action of highlighting the denominator brings us back to that concept of thinking of what can we not divide by in math. So let's make a note. Cannot divide by 0. Need to set denominator equal to 0 and solve. My answer will be all real numbers, x not equal to whatever you find as an answer, because that's what would make it 0. So let's see what that looks like. I'm taking 5x plus 20 and setting it equal to 0 because I want to see what value of x would make that happen. So I'll subtract 20 from both sides. (5x equals negative 20 is what I've got. Divide by negative 5, divide by negative 5. X equals negative 20 divided by negative 5 is a positive 4. So x equals 4 is what would make the denominator 0. That's not okay. So my answer is all real numbers, x not equal to 4. (11) is going to follow the same idea. Focus on the denominator. Set it equal to 0 and solve. I'm going to leave 11 for you to finish. It's actually a one-step problem. My hint is factor. So you finish this one. So your job tonight, it'll probably only take you about 5 minutes, is to wrap up numbers 4, 7, 11, and 12. And then also, please make sure you remember to make some time to work on your Unit 8 study guide at the end of your workbook, and I will see you tomorrow. Any questions at all, please send a reminder.